Thank you. So it's as simple as that. 3G is not a local LAN. It's more, it goes wide. So you cannot limit it to a WLAN technology. Any questions from your end, please? Before. Okay, all right. Moving on, we're looking at the various components that make up network. Networking media. Networking media can be defined simply as the means by which signals, that is the data, are sent from one computer to the other, either by cable or wireless means. Now, these are set defined standards that have been developed over years, and everybody in the industry adopts these standards if you want to be able to communicate with other devices on the global network. You need to adopt these standards to be able to communicate. Now, when we talk about cable standards, that is the type of cable that we use. We all know the Ethernet cable that you connect to your computers, which has the RJ45 connector at the end of it. Now, those cables are basically, if you're able to ever peel one, most of you might never, but if you get a chance to ever work with one, you will see that we have cables in there, which we are called twisted pairs, with standardized color coding in there. Now, these color codes have been standardized so that when I pick a cable from America and I bring it to Ghana and I connect it to a machine in Ghana, it should still speak the same language. They should still understand each other. It's a standard that exists, and you cannot just get up and connect them anyhow and expect to communicate with other computers on the network. It will not work. So everybody follows this standard. And as our last lecture was stating, the fiber network also has its own standard that is being used, and everybody goes with this standard. If you decide to come up with your own, that means you will have to probably recable the whole world before anybody will understand what you are communicating across. Now, we have different types of network devices which understand the standards that have been put across. We have the hub, we have the switches, we have routers, we have firewalls, we have wireless access points, we have modems, we even have computers, the laptops, and all these devices. They all speak a standard. Now, the computers that mostly we work with, most of us are usually end users, so we are usually the clients. We talk to, when you visit a website, you are basically talking to a server. So most networks has a relationship, what we call client-server relationship. In a client-server network arrangement, network services are located in a dedicated computer whose only function is to respond to requests of clients. The server contains files, prints, applications, security, and other services in a central computer that is continuously available to respond to client requests. This simply means that when you access Google, it's a service that is being rendered. It's on a server somewhere, and you are the client. The server just responds to the request that you make. Now, as I was speaking of the standards that all these components of network have adopted, we have network, what we call networking protocols. Now, these protocols are, it's like the language that computers use to communicate with each other. It's the applications that are on your machine, like what we are using right now, Teams. If it's trying to send messages across, there's a standard that it needs to follow to be able to talk to the computer across all these networks. So the applications use specific transport protocols, that is TCP or UDP, to release information to other devices through network layers. Now, there are various layers that a packet will go through to be able to go through your network to get across to another device. There are a bit more advanced levels that we might, if we want to spend what's the name, our time, we'll end up, even 2 hours is not enough for us to go into breaking down all the various sessions of these protocols. Starting with even the application, the transport network, and then the network interface. We're trying to keep it very fundamental. So this is an introduction to you. So we'll just keep it at the minimum so that it doesn't really get you a bit confused. So this is the way these protocols are what computers use to be able to communicate with each other. So the devices and all that, they speak one language, basically. That's what it means. Now, the applications that we have, like I was mentioning, your emails, your searchable data, your e-commerce, your internet telephony, video conferencing, chat, as we are doing now, instant messaging, they all use these protocols that are out there. Any questions for me, please? Okay, so I'm going to ask my questions then. Which type of network topology are we using for this course session?
W1.
I've mentioned, okay, all right. Let me check. Fatima. Thank you very much. Can a printer be part of a W1 network, and why?
No, it's a local connection, not one location, no topology.
Okay, why do you say that?
Sorry,
why do you say it's not part of the W1 topology?
Printer is local. It must be in a local network, not in one network.
Really? Any other? Anybody else with another view? Okay, fine. Fatima, I do get why you say printers are supposed to be local, but in today's world, printers are not actually local.
Wi-Fi.
I can actually print from where I am to where you are. If there's a printer where you are, I can send a print command to that particular printer where you are, and it will still work.
Yeah, I forgot it. Yeah.
Okay. So yes, a printer can be part of a WAN topology. What are the different types of fiber optics and their usual application in an IP network? I don't know if your fiber class ended with the different types of fiber optics.
There are 3 types.
Pardon?
3 types. I told you there are 3 types.
3
The
types.
universal,
Okay.
the universal, the French, and the military.
Sorry, I can't hear you.
We're told there are 3 types: the military, the universal, and the French, which all have its own standards, but have a particular
Okay.
color coding.
Okay. All right. Thank you.
You're welcome.
All right. So I think I made it on time. Are you able to tell me what the applications in IP networks? Have you heard of single mode and multi-mode fiber optics?
Yes, I have.
Okay, so
Yeah.
was it in this lecture?
Not in this,
Pardon?
not in this lecture.
Okay. So I will not go too much into it. It might be on your fiber training session.
Yeah.
All right. All right. That'll be all for the fundamental IP for today.
Okay. Hello, everyone. Do you have any further questions for Mumen? Any other questions, any further questions, any clarifications, any views?
I have question marks. I have questions.
Okay.
Can you explain us the difference between routers, switch, firewall?
Okay, good one. All right. So basically, a switch is a layer 2 device. It communicates or interconnects devices within the same network or local area. And a router is a layer 3 device that basically transmits traffic across different domains. So most often, you actually have a switch and a router on the same network, whereby the switch connects interconnect the devices on that network for them to be able to communicate. So your local area network, for instance, has a system, all the operators are connected for them to now for that local area network to be able to communicate to any device outside that network, it has to go through a router. What the router does is it's like a traffic point. So it's like that is your traffic conductor. What it does is it tells you that if you want to go to Kaneshi or you want to go to any other place, this is where you use, or this is where you have to go through. So the router basically guides or sends your traffic outside your local area network. And what the firewall is more of a security device. It provides protection to any network. Firewalls are used to prevent people from illegally having access to your network device. So firewalls are basically security devices. It's used to also provide certain added values like policies that says who can access what information and who cannot access what other information on a network. So if I have a network whereby I have a banking application on that network and I have a gaming application on the same network, I can decide to use a firewall to differentiate who has access to this banking application, who has access to the gaming application. So firewall is basically your police that is there. I hope that simplifies it. I'm trying to simplify it as much as I can. Hello?
Thank you, Mom.
Okay.
Very
All right.
understandable.
Hello, Francis. Do you have any further question?
He didn't talk about a hub. I can see
okay.
hub.
So the hub is basically the first generation switches that were created, and they were not smart in a way. Let me put it. They were not smart, and all they did was when you send a traffic into a hub, all it does is just forwards it to every other device on the connected to the hub. So it didn't know how to differentiate what type of traffic is going to which particular device. All it does is once traffic hits it just sends it to every device that is connected to it. So that you can imagine what kind of noise is being created within that network. So it's like in a room where we are all talking at the same time.
Hello, everyone. Any further questions?
For me, I'm good. I'm good with the explanation and everything.
Okay. Okay. Mumin.
Yeah.
Thank you so much for the, eye-opening presentation. We've learned about the W1, the PAN, the P1, and the different components of the network, all the way to the topologies, the mesh, the star, the bus, and then all these types of network. Thank you so much for your time. Thank you so much for the knowledge presented. Yeah. Okay. Guys, on this note, I would like to, thank everyone that was able to make it to this module 1 training. Hopefully by tomorrow,